In order to combine literal values and variables into more complicated expressions and to transform them, we use operators. An operator takes some number of values, usually 2, those are the operands, and combines them together in some way to compute a new value. So I'm going to first talk about the arithmetic operators. So in C we have these 5 arithmetic operators. We have plus, which performs addition, minus for subtraction, the asterisk character is to multiply, and the / character is divide. We also have the percent character is the modulo operation that only works for integers or characters. Now a character is just a number underneath, so you can think of a character, and when we're doing arithmetic on it, as a small integer. So these work on floating point and integer values, and modulo only works for integer values. There are also unary operators, plus and minus. Plus does absolutely nothing, and minus negates a value. Let's talk about modulo and integer division a little bit. So when we perform division on integer values, we don't end up with a fraction because we can't store fractions in integers. So we throw the fractional part away. We throw the remainder away. So we divide 3 by 2 in C. We don't get 1.5, we get 1. Right? So in division we keep the quotient and we drop the remainder. So 3 divided by 2 is 1 with a remainder of 1. We keep the 1 and throw the 1 away. Same thing here, 17 divided by 3, both integers. The result is 5. Right? We get 5, remainder 2, keep the 5, and throw away the 2. So it's important to remember we're doing integer division, we're losing the fractional part of the quotient. Now in modulo is the opposite. We only care about the remainder. And so we drop the quotient and we keep the remainder. 3 modulo 2 is 1. Because when we divide 3 by 2, we get 1 with the remainder of 1. And the remainder is, modulo is 1. 17 modulo 3, we get 2. 5 remainder 2. The 5 doesn't matter. 2 is the answer. Okay, so that's division and modulo on integers. Division works the normal way on floating point numbers with fractions, and modulo doesn't work at all with floating point numbers. Now what happens when we try to perform one of these operations on 2 values that aren't the same type? So we have an integer and a floating point number. Well, the compiler will automatically convert or promote the smaller sized type to the larger sized type. Now remember we talked about types. We showed a picture like this. Car is smaller than int. Int is smaller than double. So if I have an int being added to a double, I will promote the int to a double. And now I have 2 doubles. I do floating point addition, and my answer is 15.7. If I have, for example, a floating point, a double, divided by an int, I don't do integer division. I promote the integer to a double, and I get 9.0, and I get a double answer 0.9. And then one more thing to think about is, what if I have an operand that's being acted on by 2 different operators? Which one comes first? Which one has the higher precedence? Well, this applies to all operators, not just the arithmetic operators. The C language carefully specifies the precedence of each operator relative to all the other operators. And so in this case, we have that in a chart. It's on page 602, I believe, in Pat and Patel. It's also on the inside back cover of the C Primer Plus book. And it's also on the reference sheet that I handed out in class. So we know from that table that multiply has a higher precedence than plus. So this expression in C will always be executed this way. The 2 times 10 will be computed first, and the result will be added to the 3. This will not be the way that a C compiler will evaluate that expression. Now on our table, we also see we've got here 16 divided by 4 times 2. So is that 16 divided by 4 times 2, which is 8, or is it 16 divided by 4 times 2, and that answer would be 2. So the answer is different depending on which do you think this means. Well, if we look at the precedence table, it doesn't help because it tells us that divide and multiply are the same precedence. So when that happens, when we're in the same precedence level, then most operators go from left to right. There are a few that go from right to left. So in this case, this is the right answer. We associate the left-hand side first and then the right side. We perform the divide first and then the multiply. Now, if you want to compute this, then you can certainly put parentheses in the expression explicitly and tell the compiler what you want. But if you leave the parentheses out, every C compiler, because of this language definition, will calculate it this way and this way. Next group of operators I want to talk about are the bitwise operators. Now these perform operations on the bit representation of integers and characters. They don't work on floating point numbers. So again, everything is stored in the computer in a binary fashion. We don't write them that way in C, but we can perform bitwise operations on them. So some of these are familiar to you. The tilde is the not operator. That takes every bit and changes 0 to 1 and 1 to 0, the same way as the not instruction does in the LC3. The AND operator, bitwise AND operator, is the same way that the AND instruction is in the LC3. We take the corresponding bits of the two values and we AND them together, and that's the result. We have an OR operator in C that we didn't have in the LC3. We have an exclusive OR. That's just a little caret symbol. In case you don't know what exclusive OR is, it's a 1 if either of the inputs is 1, otherwise it's a 0. So if they're both 1, the exclusive OR is 0. We won't use this very often, but it is in the language. Then we have left shift and right shift operators, which I'll talk about next. So the shift operators take two operands, and we take the value on the left and we shift it by the number of bits specified on the right. So with the left shift operator, the little arrows are pointing to the left, this represents the value of x left shifted y bits. The right shift operator takes the value of x and shifts it to the right by y bits. So here's some examples. Let's say we have the number 25, we left shift it by 3 bits. So here I've written the binary representation of 25. It's got a bunch of zeros out here to the left. And we just take this bit and we shift it over 3. We take this and shift it over 3. And we do that to all the bits in the number. That leaves us with 3 empty spaces over here, and we fill those in with zeros. Okay? So the result of 25 left shift 3 is this value here, which in C we could write as decimal 200, or we could write as hex C8. Remember, this is when we do binary to hex, we group in 4s. Right? So each of these digits is the group of 4 of the corresponding digits. Now if we right shift this value, 25 right shifted 3, we just move the bits in the opposite order. So anything over here in these bottom 3 bits is going to get shifted off and disappear. And this will end up here, and this will end up here, and so on. So 25 right shifted by 3, the result is 3. Now it's very important that you understand that the value that's stored in the variable x does not change when this is executed. This is an expression. This operator doesn't have what's called side effects. It doesn't change the values that it's operating on. It computes a new value based on the input value. That's very important. Another couple of interesting things about the shift. If y is negative, then this expression is undefined. If y is larger, especially in the left shift case, or either case, if y is larger than the number of bits to represent whatever type this is on the left, then this is undefined as well. And one more thing, the right shift operator fills in with zeros on the left if the value of x is positive, or it's an unsigned value. If x is negative, then whether you put zeros or whether you do a sign extension is implementation dependent. So just be careful if you're right shifting values that may be negative.